Hey, welcome to our explainer. Today we're diving into a topic that secretly runs pretty much everything, from your social media feed all the way to the GPS in your car. It's called graph theory, and trust me, it's this beautifully simple way to see the hidden connections in, well, absolutely everything.
So let's just start with a question to get the gears turning. Think about it. Roadmaps, your social network, the internet itself. What in the world do these huge, complex things possibly have in common?
Well, the answer is actually surprisingly simple. Every single one of them can be understood with one basic idea, a graph. And that's what we're going to dig into today, how this one little concept gives us a totally new and really powerful way of looking at the world.
Okay, so let's get right down to the basics. What exactly is a graph? And hey, first things first, forget about the bar charts and line graphs from math class. This is something totally different. And you know what? It's built from just two super simple ingredients. All right, ingredient number one is the vertex. You might also hear it called a node. And yeah, that's it right there. It's just a dot, seriously. But that little dot can represent pretty much anything. A city on a map, you on a social network, a computer, even a single web page.
And ingredient number two? That's the edge. An edge is just a line that connects two of those dots, two vertices. And that line, that's the relationship. It could be the road between two cities, the friendship between two people, or the cable connecting two computers. Dots and lines. That's it. That's the whole shebang. That's a graph.
Okay, so once you have that basic idea, dots and lines, you realize you can make all sorts of different flavors of graphs for all kinds of situations. Let's think of this next part like we're flipping through a graph family album, meeting all the different relatives.
So here we've got the two most common types side by side. On the left, you've got a simple graph. Think of it like a two-way street. A friendship on Facebook is a perfect example. It goes both ways. But on the right, you have a directed graph, and these are all about one-way streets. It's like following someone on Twitter. You follow them, but they don't have to follow you back. That little arrow makes all the difference.
And believe me, the family gets even bigger. You can have weighted graphs where each line, each edge, has a number on it, like the distance between cities, which is perfect for your GPS. Or you can have a complete graph, which is just a total free-for-all, where every single dot is connected to every other dot. And then there are things like bipartite graphs, which are awesome for solving matching problems, like pairing job applicants with open positions.
Okay, so now that we've got the basics down, we're going to let you in on one of the first and honestly one of the most powerful secrets in all of graph theory. It's this super simple observation, but it has these huge consequences. It's often called the handshaking lemma.
But first, we need one more tiny definition. It's the degree of a vertex. I know, it sounds a little fancy, but it's not, I promise. It's literally just the number of lines or edges that are connected to that dot. So if a vertex has 3 lines coming out of it, its degree is 3. Simple as that.
All right, so here's a little puzzle for you. Imagine you go to every single dot in a graph. You count its degree, and then you add all of those numbers up. What do you think you'd find? Is there some kind of pattern there?
The answer is so simple, it's beautiful. The sum of all the degrees in any graph is always, and I mean always, exactly double the number of edges. And why is that? Well, think about it. Every single edge connects two vertices, right? So when you go around counting the degrees, each edge gets counted twice, once for each of the dots it's connected to. And this leads to a really, really important consequence. Because the total sum of degrees has to be an even number. It's 2 times something after all. It means it's literally impossible to have an odd number of vertices with an odd degree. You can have 0 of them, or 2 or 4, but you can never have 1 or 3 or 5. And let me tell you, this little fact is an absolute secret weapon for solving tons of problems.
All right, let's see how this idea actually helps us do something practical. We're going to use this whole concept of counting degrees to solve a classic kind of puzzle that I bet you've probably seen before. It's called an Euler path, and the whole goal is to trace a path that uses every single line in a graph exactly once. You can't repeat any. This is basically the classic, can you draw this shape without lifting your pen from the paper puzzle. It just has a fancier name.
So how do you know if it's even possible? Well, you don't have to guess anymore. Our new tool gives you a simple 3-step recipe. Step 1, count the degree of every single vertex. Step 2, figure out how many of those vertices have an odd degree. And step 3, here's the magic part. An Euler path is possible only if there are exactly 0, or exactly 2 vertices with an odd degree. Any other number? Nope, impossible.
All right, let's put all this together. We're going to move from a fun little puzzle to a more strategic competition-style problem. This will really show you how these concepts are used to prove if something is even possible in the first place.
So here's the kind of problem you might see in a math competition. Is it possible to have a graph with 7 vertices that has these specific degrees? We need 2 of them with degree 3 and the other 5 with degree 2. Now, just looking at it, it's hard to know, right? But we have a tool for this.
Okay, let's just break down the data. We've got 7 vertices in total. We can see 2 of them have an odd degree, that's degree 3, and the other 5 all have an even degree, degree 2. So what does our handshaking limit tell us to do with this? Right, we add them all up. So 3 plus 3 is 6, plus 5 times 2, that's 10, and that gives us a grand total of 16. Now, the number 16 itself isn't what's important here. What's crucial is that 16 is an even number. And because that sum is even, the handshaking limit guarantees that yes, a graph like this is absolutely possible. We don't even have to pick up a pen and try to draw it. We already know it can exist. The math just proved it for us. How cool is that? Okay, so I'll leave you with a quick challenge to try on your own. What about this one? Can you draw a graph with 4 vertices where every single one has a degree of 2? First use the lemma, check the sum, and then see if you can actually sketch the thing out.
And, that really is the big takeaway here. Graph theory isn't just for solving math problems. It's a completely new way of seeing the world. Once you learn to look for the dots and the lines, you start to see the hidden rules and the underlying structure that governs, well, everything.
Have you ever wondered if there's, a simple secret to getting a handle on your money? Well, there is. And it's not about some complicated theory. It's really about understanding just a few key numbers. So let's break down the powerful, simple math that can put you in the driver's seat of your financial future. Seriously, does it ever feel like your money just disappears? Or that building wealth is some kind of secret code you just haven't cracked yet? The good news is, it's not a secret at all. Money follows very predictable rules, and once you know the basic math behind it, you're the one calling the shots. All right, so where do we even begin? Well, every solid financial future, and I mean every single one, starts with one thing: a master plan. Think of this as the foundation, the thing that tells you exactly where you stand right now. And what is this grand master plan? It's a budget. But wait, don't let that word scare you off. Forget about complicated spreadsheets for a second. A budget is just a plan. It's a clear picture of what you earn versus what you spend. It's not about restriction, it's about awareness. It's about knowing exactly where your money is going. Okay, let's make this real. It all starts with what's coming in, right? So let's just imagine you bring home 10,000 rupees a month. This number right here, this is the starting point for your entire financial world. Now, for the other side of the coin, what's going out? This is, your everyday life, rent, groceries, your commute, all those monthly bills that pop up. In our example, let's say it all adds up to 7,500 rupees. And here's where it gets exciting. You just subtract your expenses from your income. So, what's left? In this case, it's 2,500 rupees. Now, this isn't just some leftover cash. This is your power. This is the money you can finally put to work for you. So, you've got some savings. Awesome. But how do you make it grow? Let's talk about the first, most straightforward step on the path to making your money work for you. This is something called simple interest. And honestly, the name says it all. The interest you earn is based only on that initial amount you saved. It's a straight, steady, and totally predictable way for your money to grow. Let's see how this plays out. Say you've got 5,000 rupees, and it's earning 10% in simple interest. Well, after 1 year, that's a neat 500 rupees in your pocket. After 2 years, you've made 1,000 rupees. Add that to what you started with, and boom, you're at 6,000. See? Simple, steady, and predictable. But what if we could kick things up a notch? What if the interest you were earning could start making its own money? Well, this is where we unlock the true superpower of personal finance. The best way to picture this is to think of a small snowball at the top of a big, snowy hill. As it starts rolling, it picks up more snow, getting bigger and bigger. And the bigger it gets, the faster it grows. That, right there, is the magic of compounding. So here's the secret sauce. Unlike simple interest, which only grows your original investment, compound interest grows your investment and all the interest it's already piled up. It's literally growth on top of growth. Let's watch this happen step by step. You start with 10,000 rupees. After year 1 at 10%, you're at 11,000. Simple enough. But here's where the magic happens. In year 2, you're earning interest on that new total of 11,000. So you make an extra 100 rupees. That's your interest earning its own interest. So when you put them side by side, the difference is just stark. Simple interest is a steady, straight line, predictable. But with compound interest, your growth actually accelerates, creating this powerful upward curve. And over time, this small difference becomes a huge advantage. Look at this. After just 10 years, compounding has earned you nearly 6,000 rupees more than simple interest would have from the exact same starting point. That's your little snowball turning into a full-on avalanche. Now, here's the thing. This superpower, it works both ways. It can build your wealth like crazy, but it's also the engine that drives loans. So let's flip the script for a minute and understand the math when you're on the other side. At its core, a loan is just a financial tool. That's it. You get a lump sum of money up front and you agree to pay it back over time in middle installments. And the price you pay for borrowing that money, that's the interest. So when you make that monthly payment, what are you actually paying for? Well, it's doing two jobs at once. Part of it is the interest. That's the bank's share. But the other part, the really crucial part, is paying down your original debt, what they call the principal. With every single payment, you're chipping away at what you owe. And this busts a really common and honestly a very discouraging myth. People often feel like, especially in the early years of a loan, that their payments are only covering interest. But that's just not true. From payment number 1, a portion of what you pay is chipping away at your actual debt. Okay, we've covered budgeting, we've covered saving, we've covered borrowing. The real power in all of this, though, is learning to use these simple ideas to make smarter choices in your own life. Think of this as your new financial toolkit. Before you make any big decision, just ask yourself a few questions. What's the true cost over time? Which choice is going to get me to my goal faster? And maybe most importantly, does this actually fit into my master plan, my budget? Because ultimately, that's what this is all about. The math is just a tool. Understanding it gives you the power to see the real-world consequences of your choices and to confidently pick the path that is actually right for you. So now you get it. You understand the basic math that governs your money, from how to plan it, to how it grows, to how it's borrowed. You know the rules of the game. The only question left is, what's your next move?